the whole thing about compound inequalities is you're going to have, possibly some separate and or overlapping inequalities. So like you're going to have different situations. And these are totally okay, because if I wanted to think about like the capacity of a movie theater, well, I'm not going to be in business very long if I have to have more than 0 viewers. But I also can't overcrowd a theater, so 300 would be too large, so 0 is less than x is less than 300. So there's often different constraints that you can put together that give you an intersection or maybe a union, and those terms will be more clear by the end of these notes. So graph the solution set of each compound inequality. And we're given these in chunks, so they're clearly telling us that these are intersections. So here's one. X is less than 3. I would have to rewrite these in notes. And x is greater than or equal to -2. Now this and is very important. This means that it has to be a rule. It has to conform to both of those different rules. And I am going to do this through graphing. Now some of you might realize that you could already put this together in a single statement, but we're going to hang tight on that just for a moment. So I'm looking at this and I'm thinking, well, 3 is a larger value, -2 is a smaller value, and if I want to get those boundaries shown on the same graph, then I'll set my graph up going from -5 all the way up to 5 with 0 in the middle. 1, 2, 3, 4 tick marks at each stop. So just dealing only with x's less than 3, I'm going to take my pencil. And there's a lot of different ways people show this. Sometimes people show, well, x is less than 3. Don't write this down yet. They like to show it above, and then the next one maybe to the right or however. But I kind of like to just use my pencil and shade it in a little bit lightly. So at x is less than 3, I'm going to start by writing an open circle lightly. And I'm going to show my arrow heading to the right a little bit. To the left. But then for x is greater than or equal to -2, I'm going to have a closed circle at -2, and I'm going to start shading to the right. Now let me pause for a moment here. What this means is that it has to be less than 3, and it has to be greater than -2. Well, that means that this is not an option. If I put a value over there, then it's not sticking to this and requirement. Well, if I said, well, 5 works, well, 5 might work here, but it doesn't work for that part of the compound inequality as well as this. So we wouldn't be able to shade on forever to the left and forever to the right. That doesn't work for an and statement. And back to the whole pencil deal. The reason I said, well, I like to kind of shade this lightly is because, the more and more practiced I get with these, then I can be like, well, here I am with a closed circle at -2, and then I combine the final result into one problem. You could always do these in stacked number lines where then you merge the first two together. If that was confusing the way I did it, let me know and I can walk you through doing it in more steps. Problem 2. But before we move on to problem 2, let me unify this into one single statement. It's clear that x has to be in between these. So now when I go to put this all together, I can actually say -2 is less than or equal to x is less than 3. And we would read it that way when we look at it from left to right. Now I can combine those because x shows up here. I wouldn't combine those if we had like some sort of or statement because there wouldn't be an overlap. This is totally cool because x is included in the middle of them. You'll get more of those if that description sounded peculiar. A is greater than -5 and A is less than 0. I think that graphing this will be fine if I go from -5 to 0 only, but maybe just so that it looks symmetric, I'll set it up -5 to 5. 3, 4. 1, 2, 3, 4. Now if x is greater than -5, I'm going to show an open circle here and start to head to the right. Maybe I don't even draw an arrow this time. But then I'm going to have a as less than 0, so it's not a less than or equal to. And then I'm going to think, well, which direction am I heading? Well, to the left. And by only coming out a little bit each way, I was able to make that look nice. So your paper probably would look more like this as opposed to squiggly, 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 because you're using a pencil and not an iPad. The natural thing to do is to read this left to right to where you'd say, well, negative 5 is less than a is less than 0. And yes, that can be combined in one statement because the two overlap from here to there. And so from negative 5 to 0 is negative 5 to 0. It works out nicely. Make problem 3 an OYO problem, and I'm going to put the answer up after I finish writing. So pause the video and get to where you've tried it on your own. Now, let's say you only stopped at like 5, but you ended up having your arrow go here. That's not a big deal. Just make sure it's accurate. And 2 is less than p is less than or equal to 6 is how I would write this in one step of math. Let me say one more thing. These all have ands, and all of these overlap nicely. So don't get in the habit of thinking they're always this way. Like let's say I had something that had to be less than or equal to negative 3, and it also had to be greater than positive 3. There is no number that is both less than negative 3 and greater than 3. So if I had constraints like that, it would actually be a empty set, and I would write no solution. Let's check these out. We're solving and graphing an intersection. So in the last problem, we had things written separately, and there was no algebra involved, so they were a little bit more simplified to where there weren't as many steps. So let's set up problem 1, and we'll rewrite the entire equation. Now what this means is that we can break this into two parts. The first one I would say, well, negative 5 is less than x minus 4. And I'm tracing that because I can see that that's the first limitation on this, whereas a negative 5 is less than x minus 4. And if I look on the other side where I'm going to compare x, I could also say, well, x minus 4 is less than 2. Now don't get me wrong, we totally could have solved this by adding 4 to both sides. But there are tricks to these problems, and there's also some that don't always stick into our nice, neat little box. So it's usually better to break these apart into separate equations. So I look at the one on the left constraint. I'm going to add 4 to both sides. Now you might be tempted to add 4 over here, but let's finish this one all the way through, except for the graphing part. And I'm going to have negative 1 is less than x, or I'd say x is greater than negative 1. Then over here I'm going to also add 4. And I'm going to say x is less than 6. I'll box that. And lastly, we have to graph it. So let's sneak a number line in here. Now normally I would put my number lines to the right like I did in these earlier problems, but here it's like we've taken up the left side of the page or the right side of the page, so I kind of tuck this wherever space is available. And I'm thinking 0, negative 5, positive 5 works just fine. Okay, we got tick marks. 1, 2, 3, 4. 1, 2, 3, 4. And if x is going to be greater than negative 1, then I'm going to have a point here. And if it's going to be less than or equal to 6, I'm going to have a point there. And I like to look at this and think, well, it's greater than negative 1 and less than 6. So I get more confident with these, and I put the points first and then just use reasoning to think about what fits in there. And we can plug the values actually back in. So let's try this negative 1. Well, negative 1 minus 4 does give me negative 5, and that's that pivot point. Let's try out positive 6. Well, 6 minus 4 gives me 2, and that's that pivoting point. So I got a couple different ways I can check these to make sure I'm doing these accurately. I don't think that one was too crazy. Let's look at one that might be a little bit more peculiar. So here's problem 2. Y minus 3 is greater than or equal to negative 11, and y minus 3 is greater than, I don't know why I wrote ang, and y minus 3 is less than or equal to negative 8. Well, if you wrote these in your notes this way, then I don't see a need to rewrite them. So I can add 3 to this one on the side, because they're separated, and I'll have y is greater than or equal to negative 8. And then I'll add 3 on this one, and I'll get y is less than or equal to negative 5. And if I look at this, I'm thinking, well, negative 8 needs to be included, negative 5 needs to be included. I could just go negative 5 to 10, but I think negative 10 to 0 helps me more because I'm going to have that 0 as a point of reference. And I will say, well, y has got to be less than or equal to greater than or equal to negative 8, but it also has to be less than or equal to negative 5, and there I go. And this can be bound together by one unifying statement, and I would probably say that negative 5 is less than or equal to y. I did it again, didn't I? Negative 8 is less than or equal to y is less than or equal to negative 5. And we should go back to the other one and add this in. What do we get? Negative 1 is less than x is less than 6. Make a unifying statement. Go ahead and write that after number 1. Make number 6 an OYO problem and check it on Wolfram Alpha. I think it should be pretty straightforward.